Probably. All right, so welcome to Weaponizing Ansible. So this is just a talk I put together, kind of an idea. I got into Ansible not too long ago, and I've been doing a lot of the PS attack stuff, a lot of PowerShell stuff. So my concept was, why can't we do that with Ansible? Let's see, and I got to click. So like I got mentioned in, my name's Chris Grimm, architect over at Red Hat. This is my lovely little who am I picture, right? Hell, my intro is done, so I don't really need to do that. Like I said, I've been an architect for Red Hat for about 6 months now, previously working with Khaki and many other companies that have been out there doing cybersecurity engineering work, mostly supporting SPAWAR and the government sector. So kind of do a quick introduction for kind of the basics of security concepts. We're talking about red team, blue team. I'd imagine 90% of you guys are pretty familiar with what those are already. For those that aren't, obviously your red team guys are the guys that are going and offensively attacking these systems. Your blue team guys are the ones trying to protect the systems. So just wanted to cover those basics. When I've given this presentation before, we kind of gave it to a wide audience, so I wanted to be really to cover that whole thing. And then who's a target, right? Targets can be really anybody. They can be you, they can be your laptops, they can be a system, they can be people. The whole point of like the purpose of like understanding of who a target is it can be anybody out there. So that's really like the big thing to keep in mind. It's not just a corporate network. It's not just a corporate system. It's your home systems. It's you. Social engineering is a real thing. So keep those in mind and just be really aware of that. So what do we all want as a pen tester? We want shells, right? Shells are the best. Ansible can give us shells through various means, just like PowerShell can, or really any other tool can. So we want a shell. So what are the two major types of shell? We got bind shells and we got reverse shells. So a bind shell is kind of shown up here is a pretty basic setup. There's some limitations with a bind shell though. So we talk about our bind shell. It's our attacker coming usually through the front door or some sort of front door that we might have. Usually that's a firewall in that case. Attacking some vulnerable system and trying to execute commands on that. Well, so that's obviously the problem. How many times can you get through the front door of a firewall? It's not really going to work out in many cases. A lot of times they're preventing a lot of those types of ports. You may not have really easy access to those systems. Now, maybe it's a web server and you happen to have that capability via a web injection or something like that, but that's pretty uncommon usually. So the next one is a reverse shell. This is like the real key to this. And the way that we're going to probably use Ansible in most of these instances. And the reverse shell allows us to take an attacker or our vulnerable system and have it report back out to us. The real benefit here of the reverse shell is we're talking the other way. If you've ever been on a corporate network or in any sort of secured environment, we all have access to some sort of outbound communication, whether it's SMTP, it's port 80 for HTTP, 443 for HTTPS. We can come across any of those ports, and we don't really care how we're going to get out, but those are all allowed through the firewall. So what it does is allows those internal boxes that already have some sort of vulnerability or compromisation on them to reach out and actually talk to the systems that I want them to talk to, and not necessarily me having to try to break through some firewall to get in there. So real quick little quiz. So what is Ansible? Who's familiar with Ansible? Show of hands. All right, so we got a few people out there. So hopefully you guys are fairly familiar with it. You know, it's pretty amazing. I love it. It's a really awesome tool, and we'll get into like why I like it a little bit later. It's simple to use. You know, who's written PowerShell? Who's written Bash? It's not fun sometimes. If you've ever written Ansible, and for those that don't or haven't written Ansible, I'll show that to you. It's really simple. If you can't follow it, I don't know why you can't, because you just got to be able to read English. It's really simple. Or is it a hypothetical machine capable of instantaneous and superluminal communication? Who's seen Ender's Game? I know you all have, or at least read the books. I know John has. So I'm a big fan of that. I actually watched it the other night because it was awesome. And then finally, is it an open source automation engine that automates software provisioning, configuration management, and application deployments. So for those that have actually used it, that's exactly what it is. At Red Hat, we support it. It's out there free and available for anybody to download. We've also got some paid for stuff that you can get behind that. I'll touch on briefly a little bit later. So it's all the above, right? It's all those things. All right, so how does Ansible work? That is kind of the real question. So we want to Ansible all the things, and what can it do? It can manage system states. It's a full automation tool. It can be a deployment tool. We can go out and deploy web apps with it. We can deploy an entire build with it. We can provision systems with it. We can do anything of that. It can be an orchestration tool as well. So we can have it trigger from something like CloudForms or any other system. Jenkins can trigger it to web app deployments, things like that. So we can use it for all of those things. The playbook. So I kind of talked about, oops, one more. So this is what a playbook. This is essentially, for those that I kind of reference to, this is our PowerShell script. This is our bash script. This is what it is. It's just a YAML file. In this case, this one's might be a little bit more unique to follow, but it's just a very quick example of what our playbook looks like. And I'll show you the actual offensive playbook we'll use a little bit later too. It's not going to look all much more complicated than this. It's really, really simple to follow. So in this case, we're just doing an unarchive here. We're just going to unzip that file. So we're going to go out, we're going to download that file. That might be a local source, might be a remote source. We don't really care. We're going to unzip it. We're going to unzip it to that destination. So it's pretty simple to follow. Does that seem complicated to anybody out there? So that's really all the playbook is. So what's required for Ansible? Ansible is a very, very lightweight capability. So it's built on a managed host client type system. So we're completely agentless. I don't require any sort of application to reside already on the target system with the exception of Python. Python 2.6 is really preferable, especially for the latest versions. Really, you can go back to Python 2.4, but it's not so great. You get limited on especially a lot of the modules that are out there. And then the target systems, as we kind of make mention here, they can be SSH or WinRM. There's also a couple other solutions. We can use SFTP. I think SCP is capable of supporting that communication as well, if I remember correctly. So we mentioned SSH WinRM. Well, WinRM exists on Windows boxes. Yes, Ansible can manage Windows boxes. In fact, there's a last look I saw, there are about 50-ish modules that we support natively to manage Windows systems. Everything from creating users, modifying group policy, really anything you can do. You know, as a system administrator, we want to do all those things. So, don't like PowerShell? Ansible, it works. So, yeah, kind of just covering those. The whole workflow, and I skipped off the screen. So the workflow, we design a playbook here from the control host. We can then push all of those playbooks out to the managed hosts that are out there. Really simple three-step process, just to let you do those things, let you do all of the management efforts that we've already talked about. So why would we use Ansible offensively? This is why you guys are all here, right? We want to know how we can do this. So we talk about PowerShell. PowerShell's been massive lately, big, living off the land. Ansible does the same thing. Especially, I think, in 7.4 of RHEL, we actually just launched it. Ansible's already natively there. So you don't have to go out and download it. It used to be in like the extra repos. You have to go down and download from Apple, all that fun stuff. You don't have to do that anymore. It's already there. So it's going to become more and more native already. But anybody that's managing a large Linux system's probably already got Ansible installed because that's just the way of business nowadays. And everybody out there, and I promise you everybody, is moving to Ansible. I'm on engagements almost weekly, it seems like, for a new Ansible engagement. So we want to live off the live below the radar. We want to live off the land. We want to have that legitimate traffic. I think everybody's pretty familiar with living off the land. For those that aren't, the concept is really about trying to look like legitimate traffic, look like the system administrator. So we're doing things like PowerShell's out there today. PowerShell, right? It's great. So we're doing things exactly like PowerShell does. We want to, like, those same tools that system administrators are utilizing are the same tools we want to utilize. It's really, really easy for us to get ourselves caught up into well, let's play with Metasploit. Let's do this thing. Let's create this really crafted, unique attack. Let's use Empire. They all create these really cool attacks, but a lot of them might not really be what looks like legitimate traffic to us, especially if we're doing real IDS, IPS stuff, or we're doing really auditing our networks to try to figure out what's going on. And IDSs and IPSs are getting really, really good at catching those malicious, crafted packets. So we want to do things like a system administrator does. As a hacker or an offensive guy, I'm using their accounts to do their stuff anyways, so let's look like them. And we're doing the same things. We're uploading files, we're downloading files, we're executing files, we're creating users, we're deleting users. That's all we do. That's all a system administrator does too, so why can't we look like them? So I mentioned this a little bit earlier. This is just kind of like a complexity screen. Let's talk about the complexity of PowerShell. This is just something I grabbed. it's pretty hard to read compared to what you guys probably just saw earlier with the Ansible stuff. It's pretty hard to follow. Not that there's anything wrong with PowerShell. I love PowerShell. Jared Height wrote the PS Attack stuff, and PS Attack is awesome, and I really, really love it. But so I kind of wanted to kind of open the doors for everybody to start doing that with Ansible. Bash. Who's Bash scripters? Everybody's Bash scripters, especially if you're on a Linux box. Bash is no more friendly. Let's be honest. Here's our kernel panic, right? How many times have we written Bash scripts and caused these things to happen? This is, again, kind of looking at the complexity of our Bash scripts. They're not pretty either. Not exactly hard to read, but then again, for some people, not exactly easy to read. Talk about that playbook, that YAML file, and it's a whole lot easier to read. Doing similar stuff, they're not a one-to-one, admittedly. That was a whole lot of work to try to write a PowerShell script and a Bash script to do all the same stuff. It's a whole lot of work. But we do that on the back end with Python with the modules. And so all of that you might do through a Bash script with like a big giant one-liner or something like that is just going to handle via unarchive. That's, untar or whatever. So demo time. Live demos kill presentations, don't they? So I've actually done this in a PowerPoint presentation style here, but I'm going to live demo it for you guys anyways, just because, well, that's more fun. So let me see if I can get these screens over there for you guys. Let's see if these are going to be visible. That'll be the next cool question. I'm going to show a few, and we can walk through the presentation for afterwards too. And last one. All right. So where are we at? There's no easy way to hold this thing, is there? All right. Let's try this. I'm going to put that down. All right, so I don't know if anybody can really see this, and I can pull it up on the slide deck, but this is what our YAML file looks like. This is our actual offensive YAML file. So we can definitely do that. And so we talk about our reverse shell. So this is right here. We're just going to grab the reverse shell. All we're doing in that case, we're actually just going out, we're downloading the file, and pulling it in, making it executable. And I'm being told they can't see very well, so let me see if I can bring this. That's not helpful. All right. It's all right, because I have it in a bigger picture. So the first one we're just talking about, that's just using the get URL module in this case. We're just pulling down the file like I mentioned. So we're just going out to any website out there. In this case, it's the attacker IP. That's going to be my Kali box in the demo. And it's just going to download the file. It's going to put it in the home directory. You put it wherever you want. I don't really care where it goes. It's going to work either way. And then we're just going to change the permissions on it. We're going to allow it to be executable. You can do this in a few different ways. Using the mode is really simple for that. The next thing we're going to do is we're actually going to execute this. We haven't really talked about what this is yet, but it's a reverse shell. So we're actually going to download this executable, and then we're going to execute it. We're using no-hup and exit here. The big reason is every time Ansible connects out, it actually creates a new connection for every command it's making. That's just the way that Ansible is built to be able for scalability reasons. And we want to no-hup, but every time I were to do that, I would lose that connection. So if I didn't no-hup it and background that, we would end up losing the shell, which is not really bueno. And then finally, we created this last one to go in and create a user for persistence. It's just an attacker user. It's very simple, very straightforward, not overly special. We can create any user we want. In this case, we also gave them wheel access because, well, we don't want a user with no permissions. That's no fun. We're also assuming in this case that I have some sort of root permissions on the box already. We don't have to have that. In the playbook I've got built, actually at the bottom of this right here where you don't see, it says ignore errors. So I can actually connect in as a regular user. I can connect as any unprivileged user. As long as I can execute a file, they can run these top two and I can still get a reverse shell back. So anything's possible. It's really come down to your idea. What can you do? This is a very basic concept of something fairly malicious, right? We're getting a full reverse shell, interpreter shell, in this case. And it's anything that we want it to be. So feel free to explore what's available out there. So continuing through the demo, this is kind of our setup. So on the Kali box, and I can't show the screen very well because apparently, trying to blow that up isn't pretty. So we'll keep down this way. So what we did, we just set up the Apache server on the Kali box. And then we use MSF Venom to go ahead and create a executable, which is using Meterpreter already, Meterpreter reverse shell. For those that aren't familiar, MSF Venom is just a piece of the Metasploit framework. Lets us build binaries. We can push that out into all kinds of shell code, anything we want to create our exploits, and just have a reverse shell. In this case, we're just doing a binary that's going to call back to our Kali box on port 4444, just because it's easy for the demo reasons. It could be port 80, it could be anything you want. Definitely create any sort of shell module or shell that you wanted to create here. This also does Windows, it does Linux, anything you want. So you want to build a snowman? Sure, we like building snowman. All right, so this is the playbook running. This is the output of actually running that offensible.yaml playbook. To do that, we're just going to run ansible.playbook, offensible.yaml. That can be any name you want, but that's just the name of the playbook in this case. So the first thing we see the playbook going out. We see it do the gathering of facts. That's just trying to reach out and find some information about the box. It's going to pull all kinds of information. Feel free to delve into the module setup module. It gives you an insane amount of information about a box. Anyway, so we talked about in the YAML file, we're going to go ahead and download that reverse shell. So that's the very first task, which is get reverse shell executable. We're actually going to go down and pull that out. You see it changed in this case because it's saying we actually did something. If it didn't do anything, it might just say OK. For those that aren't familiar with Ansible. The next piece, we're going to execute that reverse shell. So that's running that shell module, or use that shell module to run the no-hup command, just to create that executable and actually to run that executable. I apologize. And then finally, we created our malicious user. So we created that attacker account. We gave it wheel access because we happen to have permissions. If we didn't have permissions, because the ignore errors there, we might get an error, but that's fine because the shell is still going to execute, just going to execute as a regular user. So make it so, number one. Finally, this is the actual result of running that executable. We made it happen. It happened. It worked. So we actually have a full Meterpreter shell at this point. In many cases, that might be some sort of permissions that actually have some power. You might have root there. But if you don't, we built with MSF Venom an actual Meterpreter shell callback. So it's not just a regular shell. So at that point, I can then continue to use Meterpreter to privilege escalate if I needed to. Maybe I can't. Maybe I can because there's maybe a kernel exploit available. But it doesn't matter. The point is I've got a shell. And even as a regular user, you might be able to find some sort of other exploit on the system that Meterpreter doesn't already have. Finally, we're just kind of going over the user that was created. So down here at the bottom, we created our attacker account. As you can see there, that attacker account was created, and it does have wheel access. So this user is a fully privileged user. In this case, it can go ahead and install boxes. It's full sudo permissions, right? So it can go ahead and escalate itself to root. It can perform any sort of sudo commands if you want to try to put in the logs that the attacker did that. I'd rather say I'm root doing it. It makes it a little bit better and a little harder to find. So there's more, right? We can always do more with Ansible, especially when it comes to attacking. Like I said earlier, this is a very basic example. We can do a lot of stuff. We can deploy netcat, do some netcat listeners. We can deploy anything that you can imagine. Again, it's an automation engine, right? We talked about that a little bit earlier. It can connect to all these boxes. It can do stateful. It can check the state of the systems. It can deploy systems. It can do anything a system administrator does. So that really kind of leads us to the capabilities of Ansible. And I talked a little bit earlier about how anything's possible. And that's really what it boils down to. Is any automation engine, you can do really anything that's out there. If you can come up with the idea in your head, you can do it through command line. You can do it through Ansible. So we did demo this for a single box, or showed you guys the demo for a single box. In many cases, especially as pen testers, and kind of what brought my kind of idea up when I came across Ansible and started playing with it, is persistence. Persistence is hard. It's really difficult to deal with 1,000 systems out there when you're coming into an engagement, and they've got 500, 600, 700 boxes, and you've got to exploit them, and then keep track of them and be able to get back to them. Many times you lose connections, things like that. At least this allows us to then deploy across the entire enterprise if we happen to have permissions that have that. And user propagation is huge. So if I can go and say, all right, let's deploy this shell to one box, or I can deploy the same exact thing using full agentless communication across 1,000 boxes, assuming I have permissions, there is no better way to propagate throughout a network than using Ansible in this case. All right, so we're going to talk about defensive stuff here. Don't uninstall Ansible because it's horrible and it does evil things to you. You wouldn't go out and do that to PowerShell, right? PowerShell is really, really awesome for system administration. So don't go out and uninstall Ansible if you have it today. It's really, really good. It was built to do a lot of things. So the key being is it's also a defensive tool. You know, we're going to use it offensively in this case, but we can definitely use it defensively as well. We've used it for a few different things. In particular, we use STIG deployments. You can deploy host-based protections. Patching, you do full patching. You do this a lot for a lot of customers. And then we have Ansible Tower. I'll talk a little bit about that for those that aren't familiar with Ansible Tower. So STIGs. Everybody loves STIGs. We're in Charleston. I'm going to guess about at least 50% of this audience probably works for the Defense Department in some manner. So if you guys aren't familiar with STIGs, they're DISA's recommendations for doing security hardening. They're fun. Not at all.
You should do it to all your systems.
Yes, do it. Yes, deploy your STIG without any questions, and it will totally work when you're done.
Test in production.
Yes, test it in production. Yeah, so we can deploy STIGs. In fact, I've actually been helping develop a lot of the RHEL 7 STIGs today using Ansible. So if you guys are familiar with Ansible Galaxy, it's a place out there that we can go ahead and we deploy or put out, really just link back to GitHub, any sort of roles and playbooks that we've created. And there's a group, MindPoint group, that we actually contribute as Red Hat employees. And then we also have some of our own personal repos up there as well that allow you to go out and download those. So if you go out, you can install a role. And RHEL 6 and RHEL 7 are already fully out there. RHEL 7 is still being developed. But it's about 50% done. We've actually completed full automation of deployment for all of your Cat 1s and about half of your Cat 2s so far. And that's fully automated. SRR scripts, please let them die. Use Ansible. It's so much better. I promise you, you will make your life way better. So yeah, go out, check Ansible, Ansible Galaxy, and download those STIGs. They're available. It's a really quick search query. It just has a nice little search engine. You can just put in keywords and it'll pop up what you need. And you go out and deploy those and automate your full deployments. Now keep in mind, you will break things because it is a STIG, and the STIG likes to do all the bad things to your networks. Faraday cat, right? So we're talking about host-based protections. HPSS. I know a lot of people hate it. I was the HPSS admin. I hated it too. I still like it though. It does a lot of really great things. It's also really powerful. You know, it provides a lot of whitelisting. It provides your host-based firewalls. So we can deploy those. This is actually a really common one that we get asked when we go on engagements is, can we deploy that with Ansible? Can we deploy HPSS? Can we update HPSS? Can we configure HPSS? The answer is yes. Windows systems and Linux systems. I don't care either way. I can deploy those with Ansible. And we can deploy those across the enterprise. And that applies to any sort of application, right? We're talking about HPSS in this case, or any sort of HIPs or local firewalls. We can do those. But it does apply to any sort of application. So go out, deploy those applications with Ansible, and fully automate that life. Patching. The aliens did it. We did not patch them. The aliens did it. So patching, we definitely get this a lot, especially in Oracle. We spend a lot of time patching Oracle databases. So we've fully automated those. We've gone out. The patching process is really simple, just like I mentioned. Anything a system administrator can do, we can do better, kind of. Definitely go out. We can do full automated deployment patch deployments. It can include web applications. We can do system patching or application patching. Anything that we really can think of, we can automate it. Again, a lot of those are done through command line anyways, so we can go ahead and patch with those as well. And finally, Ansible Tower. It's a shameless plug, I'll be honest. This is our sold product that we sell from Red Hat for managing Ansible. For those that aren't familiar, Tower acts as it's kind of like a centralized management engine. If you've dealt with Ansible, especially in a non-Tower style environment, you run into a situation where you have a lot of people collaborating, and they're all working out of a single GitHub repository, ideally, or they might also be working out of some sort of shared just directory, and that becomes a nightmare, especially when you're all trying to edit files, you're trying to keep track of version control, things like that. Centralized credentials, you know, nobody wants to store all those in a plain text password file. That's horrible. Don't do it. Please don't do it. It makes me cry. So it allows us to actually centralize all that stuff. We can run jobs, we can run scheduling. Instead of trying to run all your Ansible tasks via cron, We can run that all through Tower. Again, it is a paid product, so I'm not going to hype it up too much. It is, I like it, but Tower, Ansible at the core is really the value here. It just provides a nice little GUI that lets you do that. So how can we defend ourselves from Ansible being used against us? This is kind of like one of the key things that we probably want to make sure we talk about. We talk about using Ansible for an offensive use. Well, all of the bad guys want to do it as well, especially, as a bad guy, we walk in and we see PowerShell and we are excited. If we can use PowerShell to our own advantage, we're really excited. If we can do Ansible to our own advantage, we're going to be real excited as well. So there's a few things we can do to kind of protect Ansible. Ansible's got a pretty low attack surface already, being that it's really reliant upon Python. So as long as Python's there, we can use Ansible, but that's really, it doesn't have much of an attack surface itself. But there are a few things we can do to help protect ourselves. The first being Ansible Vault. Ansible Vault allows us to encrypt our playbooks. We can encrypt passwords inside of stuff, anything like that. So what this does is allows us to, if I create a playbook and that playbook has a set of instructions that go out there that might require a password. In many cases, a lot of applications require a password to execute. Maybe I'm using something with WebLogic, whatever. And it requires a password to escalate. We can encrypt the actual password in the file, in the YAML file, and then use that password across all of our YAML files or our playbooks. Or we can encrypt the entire playbook. Maybe for some reason we want to encrypt that all. We can keep that entire playbook encrypted. And if we use Tower, Tower can manage these credentials for us, or Ansible Vault can manage those as well. Next thing, we want to harden SSH. SSH is a giant hole that we run into all the time, especially when it comes to dealing with any sort of attackers that are coming in. SSH it tends to be a front door all the time. We use it as system administrators all the time, so it's definitely something that we run into there. So we want to make sure we're hardening it. We're wanting to make sure that we're using SSH keys. We're not using passwords. SSH is really bad at trying to protect against stuff like brute force, and we all know passwords all suck because we're all using password 123. And then the next time we have to change it, we're using password 1234. And we all know that, so we want to make sure that we prevent those things from happening by using our SSH keys. We're also wanting to use strong SSH keys. Make sure we're using a large level of entropy, so that we're using strong keys. And then we want to make sure that root can't log in. Root is the root of all evil as well, but it's also kind of like the basis of what we need to do all of our work. But we don't want to allow it to SSH. That builds kind of that CIA levels into us by letting us SSHs ourselves, and then we can escalate privileges as needed for root. Privileged accounts. So we have all kinds of privileged accounts, and we want to protect those as much as possible. Oh, I need to. We want to protect those. So every layer of security, it comes into play here. Everything from the STIGs, everything from user accounts, configuring SSH, all of those types of things are definitely things that we need to keep track of. And we want to make sure that we're not letting users get additional access. We want to make sure that the user has limited permissions. We want to disable any additional access they might have, disable any sort of root access that they maybe got into, and just segregation of permissions. So that whole least privilege kind of concept. If the user only needs to do X, why can they do Y? We want to make sure that we separate those duties as much as possible. Protecting service accounts is huge as well, and then that allows us to really take advantage of that become options. So how Ansible is actually able to execute as permissions. So we actually build that in when we do Ansible. Ansible is able to connect as a unprivileged user and then escalate to a privileged user once it's across the wire. So we want to just keep those things in mind. And then finally, coming up to a quick if I can get over there, a quick Q&A session. We've got a good bit of time here. I went way faster than I've ever presented this, probably because it's always been on webinar format. So I want to open the table up for questions. Anything that anybody's done, we can also go through the demo a little bit more if people want to kind of see some different things there. Yeah, in the back.
Could you comment on any common Ansible misconfigurations that lead pen testers to rejecting their own Ansible commands?
Sure. So it's kind of a tough one from a misconfiguration perspective. The big thing is the way that Ansible is installed. it's not installed on the target system. So we talked about it's a clientless environment. So we don't have like an SSH server listening on that. We don't have an Ansible server, an agent listening. So you as the attacker in many cases, as I might be my managed node, so the control node might be my laptop. I'm the one with Ansible installed. The target box probably doesn't even have Ansible installed. So there's not really anything from a configuration standpoint that you can really do from like an agent standpoint. Where you can come into issues if you have Ansible out there and you have your own control node inside of the network. And if that node were to be compromised, there's definitely some risk there associated with maybe your playbooks being compromised, and now the attacker might have a better idea of what your network looks like, what kind of things are you already doing. Maybe you didn't use Ansible Vault and you're running plain text passwords inside of your playbooks. Please don't do that. Please don't do that. So that's probably the biggest misconfiguration that we could run into. But yeah, losing protection of your actual playbooks is probably the biggest risk, or your roles. Best case for that is you want to use something like a Git repository and have those all stored in Git, authentication, controlled, all that kind of fun stuff. That'll be your best bet to try to protect those. But that's really the best you can do from like a misconfiguration perspective as Ansible's concerned. Go ahead.
So, I mean, even if you're using Vault, though, if you have a compromised host and a playbook gets sent down, it's going to decrypt it at some point. So, I mean, even the Vault at that point can't protect against that, right?
So if the Vault is going to have to be decrypted. So when we showed that decrypted or that encrypted file, right? It's just AES-256 is what we use as base. But so to actually execute that playbook, I'm going to have to provide the Vault password to open the Vault, so then the Vault can decrypt that file or that password. And that actually is going to happen prior to going to the client or the managed host. So that happens on the control host level. So when I type Ansible or Ansible playbook and then the playbook I want to run, I then have to also specify a Vault password for that to execute. Otherwise, it's going to fail out because it won't be able to read the Vault password. So that's going to happen at the user level for you, or the administrator level. Does that answer the question?
Sort of. I mean, so by the time everything gets to the host, at the end, node you're controlling, it's all plain text anyway.
So all the community.
The Vault doesn't factor in.
Yeah. So if you happen to be on the box, the actual compromised box, and saw the execution happen, you're going to be, the limitation is going to be whatever system protections are in place there to protect that password is still going to be in play. But the communication is still going to go across SSH. It's still going to be, the communication method is going to be encrypted. But yeah, if you happen to have the compromised box and watch the playbook run, you could potentially get that out of memory when it's executing. But it's not going to be something that's in like the history command or anything like that. Yeah.
Yeah, in your reverse shell playbook, when you get your targets, if your targets file is like 50 computers in it and you run it, do you have to then tab out and make 50 listeners, or how do you manage all that?
Yeah, so in that case, especially when we're trying to do with a reverse shell or any sort of shell type stuff, we're going to have to ensure that we have a listener available for each one.
Okay.
Otherwise, you end up with 1,000 listeners, and it's not going to be pretty, or you're not going to get callbacks, right? And this isn't going to go out, like, I guess you could go out and you could actually set up a cron job to execute that shell every time. In this case, we just happened to run it one time, but then I could also turn on a cron job on that box to execute and continue to make that callback. So I got that kind of persistent callback going on. But otherwise, yeah, the answer would be yes, you would need a listener for every one. Any other questions out there?
Do what persistent listeners?
Really, looking towards the future, anything we could like sign the playbooks. It seems like the playbooks are the attack point. So if the playbook was assigned, was visually signed by someone on your team, that someone on your team made the playbook. So it's a little bit stronger than just a username password.
Yep.
That's
Sure, yeah, and we're seeing that a little bit, I think, happen with the PowerShell community right now, doing PowerShell scripts where they are signed by that. Today, that's not really happening. I don't know if that will be something that they push into the upstream. We're still open source community, so a lot of these kind of ideas get pushed up into the upstream, and then we incorporated them eventually. I don't know if that's on the roadmap at this point in time, but I see where you're going for that, and that makes a lot of sense. And that's why they built Vault for the time being. Ansible is a fairly recent acquisition, so a lot of that's being molded, especially as we look further and further into the future. Any other questions out there? So Ansible Tower provides an API. Yeah, Tower provides an API. So if you have Tower out there and you've got all of your playbooks and roles and stuff like that, you can actually call back to that. So you can do full DevOps with stuff like Jenkins. Jenkins will, you deploy your product or your code, push to Jenkins. Jenkins does the build, successful build, then kicks off into the API of Tower, which then decides, all right, now you've built your artifacts. It goes out, pulls down your artifacts, deploys, maybe spins up a whole new container for that, or it spins up a new VM, maybe a new cloud instance, whatever you want, and does a full deployment for you and deploys your application entirely, and it's all done via API. And really, yeah, the API is pretty robust, especially in Tower.
Do you know what it's based on?
I do not off the top of my head. Sorry, I don't know that off the top of my head. All right. So yeah, we got a lot of extra time, but so any other questions?
Are there any, sorry, I'm on the wrong one.
Go ahead, John.
Are there
I
any
get you.
Ansible modules that have been written to manage network gear, like
Yes.
Cisco boxes?
Yeah, so that's actually a really recent thing. As of September, officially, Cisco's been helping us develop some of their modules to handle Cisco boxes. Network device management's a tricky thing. If you can imagine doing automation across network devices, especially if you've been a Cisco engineer or done that, you make a change and all of a sudden you've blown away something or lost a connection to something and it's not pretty. So they've actually worked with a lot of us to help develop some of those. And then there's a bunch of network modules out there to do that. For Cisco, I think we've got some Juniper stuff, a few other things out there. But all of our modules, if you go to docs.ansible.com, all the modules for everything that we do is already out there. And then there's a lot of modules that exist because this is a big open source community. That's kind of our thing there. So you can create your own modules. You can write those. They are all based in Python. So you can write your own modules and do your own thing and then import those into your libraries and completely do that and push them upstream. And if they're really cool, we can do that and add those to the actual core repositories. That happens all the time. Yep.
If you're using Ansible Vault in combination with Jenkins, how do you avoid storing your vault password and playbook?
Yeah, so in that case, we're using Ansible Tower in many cases, or in almost all cases at that point. And so Tower actually has a built-in credential manager, which will do that for you, and it manages your vault passwords in a stored credential manager inside of Tower. Sir?
Is there an online community for people using Ansible in InfoSec type of framework versus DevOps type of?
So the bulk of what I've seen is it's being used very almost exclusively right now for DevOps because it's a fairly new product. And when I kind of came up with the idea of let's build an offensive Ansible capable solution, I did a lot of Googling because I didn't want to do something that somebody else had already done. And the only thing that I came across is there's a group called, that named their product Ansible. I kind of had that idea and I was like, oh, that'd be a cool name. And so I Googled it, right? And it ended up being the only group that does that, and it's not even an offensive capability. It's a deployment method for building essentially Kali on any system. That was their idea behind that. So there's nothing I've seen where it's being actively used offensively, at least not in the offensive community today. So that's kind of a lot of the reason I wanted to be able to present this to the community and say, hey, let's use this. Let's try to take advantage of this and do the best of our abilities.
Are you sharing your playbooks or?
Today I have not, though I've just written a few kind of for demo reasons. I am going to, so you guys kind of saw where I talked about Offensible. That is ultimately one of my projects that I'm wanting to build. I'm actually wanting to build those, so they're playbooks today. I'm wanting to build those into a module and actually have an Offensible module that you can utilize and make calls, but it'll be a list of playbooks that you'd then be able to just use tags to be able to call. Maybe I want to privilege escalate to a Linux box, and it'll actually build out, pull the tasks specifically that you want to run and target it that way. So at that point, they will be released. Yeah.
So I noticed in your example, you kind of talk about logging down SSH when you're kind of doing this, because at least from how I understand it, it sounds like Ansible pretty much rides off SSH. Is that correct?
Yeah, by default, that's what we do. We can definitely run off of other protocols as well. So we can do SCP. Wow, that was really hard to get out.
Right. So in that scenario, so I know you talked about Tower kind of managing some of your passwords and these types of things. Does it also manage your keys, your SSH keys, and that kind of thing?
Yeah, so those are all going to be all built in. It's going to manage those from a connection perspective, but you're going to have to provide them the keys. So there's actually a big discussion we've got going on inside of Red Hat and in particular in the Ansible community, where we're trying to figure out how we can best automate key rotation and key management utilizing Ansible, because it is kind of a new thing that we're trying to get into the security world with and finding best use cases. SSH key rotation and management is going to be definitely up there, and it's something we're actively talking about with some of even the engineers and developers of Ansible today.
Sure. So like, say from an attacker's perspective, if you ran across somebody's bots that was doing Ansible-related things, does this tower product, does it actually just reference where on disk these keys might be, or is it actually centrally managing those? So that would be like stored for you?
Yeah, those will be stored in the credential manager on side of Tower.
Okay.
Yeah, so those aren't just like sitting on the file system or something where anybody can get to them. They're stored in the credential manager on Tower.
And Tower's a paid for?
Yeah, Tower is the paid for centralized enterprise management tool.
How much is that?
I don't know off the top of my head. We don't deal with pricing where I'm at. But that's not to say that it's not available. So actually, as of September, like mid-September, we open sourced it. When we bought Ansible, it was originally not open source, and we open sourced that, like I said, around mid-September when Ansible Fest happened in San Francisco. So you can go out, it's the AWX project, and you can actually download and build it yourself. I'm not going to say it's easy to build. It's not pretty at all right now. And there's also currently not an upgrade path to my knowledge. So if a new version came out, I don't think there's an upgrade path available, but we do that all through Playbooks. So if you've ever deployed Tower, Playbooks actually, the Ansible deploys itself in that case. So that'd be your best bet if you're wanting to play with Tower. You can definitely get a hold of AWX project. So just download that and it's available on GitHub. Yeah.
So will Ansible ever provide any sort of support for just generic IoT devices or ways to look inside of those as well?
So there's a little bit of support out there already. Most of it's not directly supported by Red Hat, but there are other modules that are out there. Generally speaking, yeah. So there's Android modules out there, things like that, to do that. And then the limitation on a lot of the IoT devices is that they need to be able to support Python 2.6 or greater. And a lot of those may not have a full version of Python to be able to support that, which is the big limitation there. Yes, sir. Yeah, right in front of you, and then I'll get to you.
Ansible Tower, what kind of support for two-factor authentication or integration with authentication against Active Directory?
Yep. Yeah, so that's all there. Yeah, so we've got full LDAP integration. We've got Active Directory integration. It supports SAML authentication. It's not something that's super fun to set up. It's fairly complex, but that's any sort of SAML type deployment. They can be kind of tricky. But it supports really any way that you can think of to authenticate. We even support Radius. So any sort of two-factor style authentication is definitely available for the front end of Tower. And it's also available on the way our API connects. It does support some level of two-factor authentication there for API level connections. I'm not exactly sure how that works off the top of my head, though. Yeah.
Just curious, have you looked at any attack scenarios using Ansible pull?
Ansible pull. I don't know if I'm following what you're referring to.
Ansible has the ability to pull from the target into from a Git repo.
So that would be similar to the way that I'm doing. So you could definitely do that from an attack scenario. I see what you're saying now. So that would follow very similar to the way that I used the Ansible to kind of use a get URL style thing to pull down the malicious executable file in this case. So it could be the same thing if we're using Ansible pull in that regard. I've never used it, but I would think that if you could pull down some sort of code from like a Git repo or something like that, then I could then use it to then pull down the code, build the code, execute the code, all in the same box on that target system. If that's what I'm following, right?
Yeah, well, I haven't used it either, but I've heard it described as being infinitely scalable that way compared to pushing commands.
Oh, okay. So, all right. Yeah. So actually, that's Ansible to core. I understand your question now.
Yeah.
All right. Yeah. So that's actually how Ansible works natively. So because we're an agentless system, and this is where scalability really comes in. I didn't really talk about that very well, I don't think. So scalability with Ansible is really all about executing on the remote host. So even though I'm executing from my laptop as a managed or a control host, I push out the playbook to the managed hosts, and then the managed host is what's actually executing every single one of those commands. That's not occurring from my box. So that makes it infinitely scalable in that regard. Ansible can easily scale out to tens of thousands of boxes from my laptop. I don't need any massive system because every command is executed locally on the managed node. That's how. So when that runs, when that playbook I talked ran, every one of those commands were executing locally. I wasn't pushing those commands to them. I pushed out one time, and then we do some serialization and parallelism that you can do as well. So if you are talking 10,000 plus hosts, I can have it serialized groups of parallelized groups. So I could say I'm going to run 100 here, and then 5 minutes later I'm going to run 100 here, and I'm going to push 100 so you can scale it out across. Or you can do, depending on how much of a network you have, if you have Tower can support even further, and even more simultaneously. Each tower can support roughly, I think if I remember right, it's about 500-ish to 700 nodes per tower instance. I saw another hand somewhere. Okay, 3 minutes.
How does it handle error logging? So if you're pushing to the client and there's an error, is it sending it back to your node?
Yeah, so there's all kinds of error logging available, and any sort of standard error or standard output that you get from those commands is going to be kicked back to you. Ansible is going to default fail on any sort of error that occurs, but you can do stuff like verbosity and get more results back, and then you can do stuff like ignore errors. So like I mentioned when I created that user account, if I didn't have permissions, it could ignore those errors. It also does some stuff like error handling as well. So I could do stuff, I could do a block. So it's essentially a catch statement. So if this fails, do this, else do this. So it can do all of that as well. And that gets into kind of how you handle blocks and error handling within Ansible. So we're coming up on the end of time. So any last questions? All right. Thank you very much. Appreciate it.